All right, thank you, Michelle, for the kind introduction, and thank you to WasteCon for giving us the opportunity to present some of the technologies that we provide to the industry. As you heard, we'll be talking about dirty MRFs and some of the technologies that we use in those. I will tell you a little bit about our company, our group of companies, very quickly. And then essentially I will do a walkthrough of some of the important areas in a dirty MRF where technology can help you increase the recovery of your recyclables. As a group, the CP Group is a family-owned company based out of San Diego, California. We have two main divisions. One of them is operations. We operate our own single-stream MRFs. We have electronics recycling facilities. We have non-ferrous scrap yards, etc. And then we have a manufacturing branch. And the manufacturing branch consists of four companies, basically. CP Company, CP Manufacturing, is a turnkey system supplier. We have Cross Manufacturing, which is a specialist for construction demolition facilities. MSS, which is the division I work for, we specialize in optical sorting equipment. We have IPS, which is our baling company. We manufacture a full range of balers. There's actually also a fifth company that was added recently, Advanced MRF, which specializes in controls for all advanced controls in all these types of facilities. So what I'll be doing, as I mentioned, I'll show you a little bit of an overview of the different technologies that we use or would use in dirty MRFs to increase the recoveries or the recovery of your recyclables out of those streams. So what defines a system design? Very important to what goes into the system design is where does the material come from and what is the approximate composition. For example, household versus businesses. Does it have low or high organic content? So geographical consideration, where is it located? Are you expecting for the recyclables to be a fairly high percentage or a very low percentage? Is the material coming in bags or not? So those are all issues that we have to look at on the incoming material side when we design a system that can try to increase the recovery of recyclables as much as possible. Then of course on the outside or the outgoing end of the facility, we have to look at the different specifications of where the different products will go. Will the products at the end, the material that's not recyclable, will it just go to landfill? Will it maybe go to be converted into RDF, which may require specific particle sizes, etc. What is the throughput that we need to process? What is the equipment that we really need to in order to achieve the goals? Or do we have some items or some technologies that we would like to have but may not be absolutely necessary? So those are all things that we have to look at when we design a system. So the areas of interest that I'll be talking about, and most of this is going to be very visual, so I'll just show some pictures of some of these areas so you kind of get an idea of what some of this equipment looks like. We have the in-feed area, we have the manual pre-sort, which we'll have probably in most of these types of facilities. Some of the facilities may have a backbreaker or a shredder. We have sizing equipment, where we size the material into different sizes, whether we use trommels or screens. Then we use actual separation equipment such as magnets, eddy current separators, optical sorters. Then of course once you've done that, you need to store the material, you may have to bale it, etc. So I'll show you some examples of these areas of interest in these facilities. When we look at the front end where your material comes in, there are several options on how you start feeding the material through these systems. So these are just some pictures of some conveyors or conveyor designs that we use for some of these systems. This would be a system that we built that is located outside, as you can see, and it's above ground. Not in all locations will you be able to put the material into a pit, but if you are, then it would look something like this. One of the important things is obviously what the quality of the conveyors that we built. The ones that you see on these pictures here are steel belt, double beaded pan belts, so very extra abrasive resistant. and able to handle the dirtiest and wettest and most abrasive types of materials. Then one thing that is very important and will somewhat define the quality of the sort coming out of the system is how you meter the material through the facility. So you want to make sure you have an even flow of material going in, and that will allow you to design the process and operate the plant to the maximum performance. So we have different methods of doing that, again, mostly depending on what the input material is. These here are what we call metering drums, so they're kind of work like a rake back type of system on the incline conveyors to make sure that not too big surges of material go into the system. The next step, as I mentioned earlier, most of the time we will have a manual pre-sort station to make sure no materials go into the processing system that might actually damage the equipment downstream. So a pre-sort station might look something like this. If it's inside an enclosed cabin that may be heated or cooled, may look something like this. The one thing that our group of companies does not manufacture are shredders, but if the material comes in bags and you have to open those bags, there will be some sort of process that you will need to use to open those bags. One of them is using shredders or bag openers, but essentially they rip the bags open in one way or another to liberate the material from each other. Here is a picture of such a bag opener. Again, depending on the material and what you are trying to do at the end will define whether we would use a shredder or whether we would use a bag opener. I mentioned the sizing of the material. That's normally one of the first steps as far as the separation goes. We will have to separate out the very small particles, we'll have to separate out the very large particles, and try to process these different sized streams individually, because you will get a much better separation with all the equipment downstream if your particle size is somewhat controlled into the different groups. So one of the components we use for sizing are trommels, which you can see some pictures here. And those are quite big, as you can see, 12 feet diameter, 75 feet long. So if you need a high throughput sizing component, one of these large trommels will do the job. This is actually a picture from an installation in the San Francisco and the Bay Area. Besides trommels, again, depending on the material stream, we may also use finger screens or bar screens. This is not a component that we manufacture, but again, depending on the material, this might be a very good solution as well. One of the next pieces of equipment that might be required are air classifiers, where we sort or separate very heavy items such as concrete blocks and very heavy items from the lighter materials such as plastics and paper and things like that. Because again, if we're trying to do a good job on the downstream sorting, it's good to try to segregate some of these different categories, whether it's sizes or by weight, as much as we can. We have, let's go back up, we have two types of air classifiers that we use. We have a two-way air classifier where we separate it simply in a light fraction and a heavy fraction, or we have a three-way air classifier where you have a very light, medium to light, and a heavy fraction. Again, depending on what you are trying to do or what your goals are, you might use one over the other. One of the pieces of equipment that we use to actively extract one of the valuable materials out of the stream are magnets. Depending on what the system design looks like, what the material is, we may use a drum magnet, which you see here in this picture. We may use overband magnets, and obviously both of those will remove or extract the ferrous materials. As I mentioned, if you have the different sizes, or let's say a 0 to 2 inch, a 2 inch to 10 inch, and then 10 inch and large, you would actually have magnets on, or the separation equipment that I'm talking about, on each of these lines to get the maximum recovery out of all these different sizes streams. One of the pieces of equipment that will provide you a very high revenue generator are eddy current separators, because they will be able to extract aluminum cans out of your municipal solid waste stream. And so obviously aluminum cans are very valuable, so this is definitely a piece of equipment that is going to be worth your while investing or integrating into the system design. One of the next steps that you could do for separating or segregating out materials even further would be optical sorting. We use near-infrared and color type optical sorters to identify the different types of material. So you would be able to extract, for example, fiber out of the mixed stream of materials. You would be able to sort out specific type of plastics like HDPE or PET. Again, depending on what your material composition is, it may be worth doing one over the other. And these are just some pictures of some installed units for these kinds of applications. At the end, a lot of times the material that comes in, as you know, in a dirty MRF will be very dirty, so none of the pieces of separation equipment that I show you is going to work at 100% all the time and not generate a 100% clean product. So in most of the cases, we would add manual QC stations for a final cleanup of the product so that you actually have a saleable product at the end. Once you've sorted it all, you will need to store the material in one way or another. In most cases, we would not have a compacting or baler for each of the commodities. We would store the commodities and then bale them or bale them on one central baler. So we have different ways of storing the material. The picture that you see here shows long bunkers with walking floors at the bottom of them. So they'll be able to store large volumes of material. We have others that are similar, but instead of a walking floor, we'll use a conveyor at the bottom of the bunker. This is another picture of, you can see the conveyors that would then walk out the material from the bunkers and onto the baler feed conveyor. For materials that are like containers, cans, bottles, we most of the time will use these kind of cage silos because we can build them very high, so we can use the space in the facility very effectively. And those would empty out directly onto the baler feed conveyor so the materials can be baled. Talking about the balers and the baler feed conveyors, this is what they look like. Again, we would normally recommend using a central baler to bale all the different types of materials. This is kind of what they look like. Again, our group of companies offers these types of equipment for the complete facility. At the end, again, in a dirty MRF, you will have, what we're trying to do is extract as many valuable or recoverable items as possible. So you will have, obviously, residue or garbage left at the end. So there are different ways to handle that. Either you go into large roll-offs or transfer trucks, go directly to the landfill, or you have a solution with compactors, like shown in this picture. A little bit more about the systems and what goes into the systems, just as kind of rounded up. If you are in a climate where, again, the sorters or the people that are working in the facilities, if it's really cold or really hot, we use sort cabinets that can be air conditioned or heated. They'll look like this. And obviously, it's very important that these systems are quite big, so you need to control, the controls of the system are very important. So we pride ourselves in having a very user-friendly interface for the operators to learn about or to evaluate what the equipment is doing at any given time. We have these portable control panels where the shift supervisor or the operations supervisor will have it basically in his hand at all times what is going on in the facility. If there are any shutdowns, he will know immediately why that is and wouldn't have to walk to a simple cabin somewhere and try to find out and lose what's going on and lose valuable time that way. The same controls package will also offer you some maintenance software, so it will tell you, it'll print you out every day what you have to do on the maintenance side. As you can imagine, these systems, because they are so big and because they process quite a dirty stream, there will be maintenance involved on a regular basis, so this will allow you to track and monitor all that very nicely. We're obviously putting a lot of focus on health and safety of the equipment during the installation, obviously while it's running, with e-stop, lockout procedures, etc. So we are fully compliant with all the standards that are required from that side. One of the things that we've started putting in that's become more and more important also, again, mostly to observe and monitor what is going on in the plant, is video surveillance of all the important areas in the facility, so that from a central computer or a control station you can monitor at all times what is going on. So this, as the technology and the components have gotten less expensive, we've actually started putting those in on a regular basis in many, many facilities. Important as an operator, if you have equipment or components that go down, you will have to have spare parts to do that. So obviously, besides just the equipment and running it, you know, having the right spare parts and all that is very important. We provide almost a class at the beginning when we start up these systems. So as part of our startup support, to help the operators and the people that run the facility understand what they need to do and why. And so we integrate that into part of our training of the operators. So I hope that kind of gave you an overview of what these systems look like, what are the areas of importance in some of these dirty MRF systems that we designed. Again, as a group of companies, that is one area where we built those systems. As far as the number of systems that we install, most of them are still in single stream and dual stream MRFs. But definitely from an overall market standpoint, this is an area that is growing in North America, and we're seeing it more and more that we're starting to put these systems in. So with that, I thank you very much, and I hope you enjoy the rest of the talks. Thank you.